This is R.D. Sharma Solution, Class 12th, Chapter 11, Differentiation. Exercise is 11.2. So in this exercise, we will be using the direct results. So here are certain direct standard results of differentiation, and we have already done most of them using the first principle. So this exercise has more than 70 plus questions, and those where only these final result will be used, we'll employ that. So we have differentiate sine 3x plus 5. Now remember, this sine, if I assume it to be sine theta, so first we have to do the differentiation of sine theta or sine whatever the content is. Then we have to differentiate the 3x plus 5, that is theta. Then whatever is inside, means we will go up to the limit where the differentiation can happen. That is called the chain rule. Because we know that sine theta, the differentiation is simple cos theta. But here we are dealing with sine 3x plus 5. So what we have to do here is d by dx of sine theta means first you have to do it the normal way, cos theta. Whatever is theta, 3x plus 5 you can write. Now you will not stop here. Using the chain rule, you will also differentiate 3x plus 5. That is d by dx of 3x plus 5 has to be done. D by dx of x is 1. You don't differentiate the constant value, it always comes outside. And a simple constant value is going to give you 0. That is, this cos 3x plus 5 will come in front. And then d by dx of 3x plus 5, how to do this? D by dx of 3x plus d by dx of 5. So this constant, it always comes out. So you can call it as 5 into d by dx of 1, that is going to be 0. And 3 into d by dx of x, that is going to be 1. D by dx of x is 1. This is for x. If it is, can be assumed to be power of 1. So 1, this is nx to the power n minus 1. 1 comes in front, and then x to the power 1 minus 1, that is x to the power 0. And anything to the power 0 is always 1. So the result of x d by dx is 1. So only 3 will come. The d by dx of 1 is, of course, it is a constant, so it is going to be a 0 value. So cos 3x plus 5, whatever is coming, that is 3 is coming, that you can write in front. Differentiate tan square x. Now same thing we are going to apply here. Same way we have to do this. This is tan x. Assume it to be, say, some y. So basically you are differentiating first y square. So d by d, whichever, I am writing y, so I am just writing y in the denominator. It is not like that, just to make you understand I am doing this. So d by y of y square is 2 into d by d y of y. That is nx to the power n minus 1. So this is simply 2y. So d by dx of tan square x is 2 into tan x. Now you have to differentiate tan x also. That is chain rule. So now 2 tan x, and again differentiation of tan x is sec square x. So sec square x, and this is going to be 2 tan x sec square x. Okay. So this is how it is done. Okay, this question, this is simple question which we already saw in the first part. But the only catch here is, if you take d by dx of tan x, it will be sec square x. But we have a degree here, and we don't differentiate when it is degree. We always convert it into radian. So you need to convert first it to radian, and then you have to differentiate. Because 180 degree is equal to pi radian, or pi radian is equal to 180 degree. So in order to convert a degree into radian, you have to multiply it by pi by 180. Alright? Because 2 pi is equal to 360 degree. Pi radian, 180 degree. 1 degree, pi by 180 radian. So tan x degree plus 45 degree, whatever value comes, that has to be multiplied or converted to radian by multiplying it by pi by 180. Now you can differentiate it. You can only differentiate when you convert first. That will be used in other questions also. So you need to keep this in mind. So first thing is tan theta is sec square theta. It's sec square theta. And then we have x plus 45 degree. This is not degree. X plus 45 pi by 180 because it is radian. So sec square theta. Then you have to differentiate the inside one also. That is chain rule. So this d by dx of x plus 45 into pi by 180. You don't write degree now because you have already converted it. What is the differentiation of this? You can assume it to be x into pi by 180 plus 45 into pi by 180. So d by dx of this and d by dx of this. See, this is whole constant, so it is going to be 0. This x into pi by 180, so pi by 180 will come in front. D by dx of x, that is d by dx of x is 1. So pi by 180 it will be. And that pi by 180 has to be written in front. So this is your final result. So finally the result, because the question is given in the degree, so you have to convert this into degree. Not you just don't leave it like pi by 180. You have to write it in degree. So it will be x degree plus 45 degree of sec square pi by 180. Sine log x. So first you have to differentiate, assuming it to be sine theta. Then the next one will be to to differentiate the log x. Alright. So this sine x differentiation is simple cos x. So cos log x it will be. Theta is log x we have assumed, right? So cos log x. Then you have to differentiate log x because the chain rule. You will keep on differentiating until nothing is left. So d by dx of log x is going to be what? Log x differentiation is 1 by x. 1 divided by x. You can see the standard result also here. The 12th one I am showing you. This 12th and 15th, because if the base is E or the base is A, it behaves differently. So cos log x, d by dx of log x is going to be 1 by x, and that is going to be your final result. This is going to be your final result. Please remember standard result and also then chain rule. These are the two things you need to take out from this discussion. First, assume it to be just theta. Then you have to differentiate whatever is theta. And if it is log x square, you have to differentiate log x square, then x square also. So step by step you have to go till the time nothing is left to be differentiated. This is e to the power sine root x, e raise sine root x. And ex, assume it to be e theta or e to the power y. The differentiation of e to the power x is simply e to the power x. There is nothing, no change. Whatever is different, you are differentiating, you just have to write that. So e to the power sine root x, the differentiation of this d by dx of this whole expression or term will be same thing. E to the power sine root x. Then you have to differentiate sine root x. What is sine root x? Again, assume this root x to be theta. So sine theta is cos theta, d by dx of sine theta is cos theta, so cos root x. Then you have to differentiate root x. D by dx of root x is what? 1 by 2 root x. Now this result you know already, because this d by dx of root x is 1 by 2 root x. How has it come? You just see here or assume this not to be root but x to the power half, because it is actually x to the power half. So just apply n x to the power n minus 1. So half x to the power half minus 1. Half minus 1 is negative half. So this negative half to x to the power negative half is 1 by x to the power half. That is going to be root of x. So 1 by 2 root of x, that is how it has come. So final, you have to combine all these results. First was e sine root x. Then you have cos root x. Then root x was 2 root x, 1 by 2 root x. So this whole is the result of this differentiation. differentiate e to the power 10x. Same thing, because e to the power something, differentiation will be same thing, nothing will change. So d by dx of e to the power 10x, e to the power theta, whatever you call, is same thing, e to the power 10x. Then you have to differentiate 10x. d by dx of 10x is sec square x. So it is going to be sec square x and e to the power 10x. You can write whichever you want, first or second, but it is always advisable that those terms, because here you see everything is getting say intertwined. So in order to just differentiate them, we have written sec square x first and then e to the power 10x later. Differentiate sine square 2x plus 1. Again, it is sine square of something. Assume it to be say some x square or y square. So sine 2x plus 1, it is whole square. Assume that you are differentiating something, say y square. So d by dx of y square is 2y to the power of 2 minus 1. And x to the power n minus 1 I am applying. So it will be 2 sine 2x plus 1 and 2 minus 1 is same thing. So 2 sine 2x plus 1 it will be. And then you will not stop here. You have to differentiate 2x plus 1 also. So no, sine differentiation first, then 2x plus 1. So d by dx of sine theta is cos theta. So it will be cos 2x plus 1. Now the third chain, because 2x plus 1 is still in the chain. So you will differentiate d by dx of 2x plus 1. And how to write this? D by dx of 2x plus 1 is 2 into d by dx of x plus d by dx of 1. d by dx of 1 is 0, constant is always 0. And then 2 comes out, d by dx of x is 1. So this whole result will come. Okay. Now there is one more thing. You will not stop here. Because if this differentiation gives you or it points to some standard result, you will use that result, because sine 2 theta is 2 sine theta cos theta, which you see here also. So this 2 sine theta cos theta will be sine 2 theta. It is going to be 2 we have employed, so only 2 will be remaining. The 2 sine 4x plus 2. Log base 7 2x minus 3. Log of e base is 1 by x, but when you have log base a, that is some constant base is there, not e. Standard is e, which we write as ln. But when we write log with some base, say here base is 7. Log base 7 2x minus 3. So we will use the standard result. This is log base a and x. So d by dx of log base a x is nothing but 1 by x and then log base e a in the denominator. So log base e a, you don't have to write base e again and again. It's understood. So log base 7 2x minus 3. In this case, a is 7. You can just compare this with log base ax. A is 7, x is 2x minus 3. You can just write it here, 2x minus 3 here, log base e, a is 7. Alright? But you will not stop here. You don't have to write e because it is log base e. But you will not stop here. You have to differentiate 2x minus 3 also. And 2x minus 3 is simple. 3 will be 0 and 2x, 2 comes in front, d by dx of x is 1. So d by dx twice of d by dx of x, that is going to be 1. So this is 2 by 2x minus 3, log base is log 7, you can just write. So this is your final result, 2x minus 3 log 7. Don't write e because it is understood here. Differentiate tan 5x degree. Same thing you have to do. You cannot differentiate when it is in degree. You need to convert the degree into radian first. Then you can differentiate and final answer will not be in degree. Please remember. So this is tan 5x, pi by 180 you have to convert. Alright. So tan we have already seen. Tan x is sec square x. So you can just write whatever is inside, doesn't matter. You just write sec square and whatever is inside just put it here. 5x and pi by 180. Now degree we have converted into radian now. Then only you can differentiate. But now 5x into pi by 180 is also remaining. Chain rule. So 5x into pi by 180, differentiation of that will be, constant will come out. So 5 pi by 180 will come out. And d by dx of x is going to be 1. So only 5 pi by 180 will be there. But if you write 5 pi by 180 in the end, it will be seen as, okay, this is following sec square 5x pi by 180 and 5 pi by 180. So you always write constant in the front. So 5 pi by 180 is sec square 5x degree. Always remember, you have to write in the degree. Differentiate 2 raise x cube. So 2 to the power x cube you have to do. So this is almost related to a to the power x kind of formula. And what is the differentiation of d by dx of a to the power x? It is going to be a to the power x log base EA. So d by dx of a to the power x is a to the power x log base E and then a. Now try to similarize or try to compare this with 2x to the power 3 with a to the power x. A is 2 here. And then x is x cube for just now. It is not 3 to the power 3, it is x cube. So it is 2 to the power x cube and then log base E. What is a? 2. But you will not stop here. You have to differentiate x cube also. So x cube will be 3x square. This is a standard result. Because of the formula we already know. But because of the chain rule, you have to differentiate x cube as well. So d by dx of x cube is going to be 3x square and x to the power n minus 1. But you always write this in the front. So 3x square multiplied by 2x cube log base E 2. Don't write base E. It's understood. Differentiate 3 into e to the power x. Same thing you have to do. Same a to the power x version you will use. This is 3 e to the power x, and as I told you here also, this is almost same. So log a to the power x log EA will be the differentiation of a to the power x. Now first compare what is a here. So d by dx a to the power x is, as I said, a to the power x log EA. So a to the power x is simply this thing, just you can replicate it. What is a here? 3. So now you just apply it here. X is e to the power x. So 3 e to the power x log base E. You can just skip E. This a is 3. But this you cannot stop here. You have to differentiate e to the power x also. D by dx of e to the power x is e to the power x. That is going to be a final answer. And always keep this e to the power x in the front. You have to write exactly like this, everything, in writing. I'm not writing it just to save time. So we have around 70 plus questions. So we'll be doing it later. Thank you so much.